Hi to all, how's it going? So I came about this Reddit forum post where the OP has asked how to do the strangely shaped internal pockets with FreeCAD. So I decided to give it a go. The original tutorial is a MasterCam tutorial and can be found here at this webpage. And for this particular tutorial I'm using realthunder's LinkStage3 release 10.15. and it can be downloaded from this web page. So as we've said, the difficulty with this model is modeling the internal pockets that need to have a constant depth that follows the external contour of our model. So if we take a look at the wireframe, you can see that the bottom of the pockets is parallel with the top of our model here. So let's take a second, and by taking a look at our model, let's try to find some major geometry elements that can drive the shape and dimensions of our model. We can clearly see that we have a outline that we can represent with a rectangle. We have 4 outer arcs, and the center of our model can be represented by 2 circles. Let's create a new file. In part design we will create a new body and a new sketch on the XY plane. Hit OK. We will rename this sketch as Master Sketch, and we will start by drawing the external bounding box of our model. So let's select this vertex here, and the center of our sketch, and then by pressing S on your keyboard a symmetry constraint will be applied. I will select the top line, and by pressing Shift H on the keyboard I will give it a dimension of 130 millimeters. I will select this edge here, and pressing Shift V on the keyboard I will give it a dimension of 40 millimeters, and this way we have essentially represented the external contour of the model. Now I want to have some construction geometry for the centers of the 4 holes in our model, so I will do just that. I will change to construction geometry by hitting this icon here on the toolbox. Let's choose the rectangle tool. Let's create another rectangle. Right click to dismiss the tool, select the 2 outer vertices and the center of the sketch, press S on your keyboard for a symmetry constraint. Now we will use a little trick to represent what it is essentially the radius of this outer arc here. So let's get back to our drawing. I will create a construction rectangle that is constrained to these 2 vertices, this one here and this one here. Okay, I need it to be an actual rectangle, so I will select these 2 edges, press E on the keyboard for a equality constraint. Now select this edge, Shift H on the keyboard for a horizontal dimension, and we will make this 8 millimeters. So to this point we have essentially drawn the outer perimeter of the model, and we have the centers of the 4 holes that we have here. We will actually draw these holes, so I need some regular geometry. Let's change to regular geometry. We will create some circles, and by taking care of hitting the vertices I will create a circle that will be tangent. You can see that the solver will automatically add a tangency constraint if we are over the top edge. So this circle will be tangent to the outer perimeter of our geometry, and we will do 3 others. That need to be tangent. And notice how we have a fully constrained sketch using only 3 dimensions. Now I would like to represent this center part of the geometry, and I will represent it with 2 other circles. So always 2 regular circles. Let's hit the center of our geometry. I want the outer circle to be tangent to the external of the geometry, and the inner circle to be tangent to this construction geometry rectangle. I will use the polyline tool to create some geometry that will turn useful later in the process of modeling. So right click to dismiss the tool. I will do the same under. So the points need to be attached to these circles, and by selecting this line and this circle and pressing T on the keyboard, I will give a tangency constraint between the circle and this edge here. I will do the same for the other 3 left, so select the edge and the circle, T on the keyboard for a tangency constraint. Again here, T for a tangency constraint, this one here, T for a tangency constraint, and we have this vertex here and this vertex here fixed on the inner circle, but I want them to be also fixed on the vertical sketch axis. So select the vertex and the vertical sketch axis, and by pressing Shift O on the keyboard we will constrain the vertex. So select the other one, select the vertical sketch axis, Shift O on the keyboard, and we have a fully constrained sketch. With these major geometry elements locked in our master sketch, let's close this sketch. And let's see how we can proceed to eventually get to this finished model. So let's hide some geometry here and let's go step by step. The next logical step for us would be to essentially pad the outer perimeter of the model. To do this, we will create another sketch, always on the XY plane, hit OK. And we will import some external geometry from our master sketch. So using this icon here, I will import the 4 outer circles. I know I need them. I will also import this circle here. Now using the arc tool, I will start to block out loosely the external of my geometry. And 2 on the keyboard. By taking a look at our model, we can see that our geometry is comprised of 2 other arcs here. So let's go ahead and draw them. Let's choose the arc tool. By hitting the horizontal sketch axis and trying to hit the vertices of our previous arcs, we will create this geometry here. Right click to dismiss the tool. Now choose the line tool. Try to be constrained to the vertices of our arcs, and we will close the perimeter of the sketch. A horizontal constraint was automatically added here, and we will remove it because it will create some problems if we go ahead. Let's take a look again at our geometry, and we can see that we have some other arcs here that connect the external edges with the center circle. So let's create this. To do this, I will use the fillet tool. I will select this arc here and this edge here. I will select this arc here and this edge here, and we have the fillets. This one and this one, and this one and this one. Notice how the arc tool automatically creates some nice tangency constraints between the edges. We will need to do these constraints manually for the other edges, so select this geometry and press T on the keyboard, and you will be prompted that a tangency endpoint tangency was applied, and we will slowly go ahead and do the same for the rest of the sketch where the tangency constraint is missing. So now what I want to do is to have this arc here and this arc here equal, and I need to import some other geometry here. I need this line here and this line here also. And now it is time to constrain our sketch to the dimensions from the original master sketch. I will choose this arc here and this circle here, and we will make them equal by pressing E on the keyboard. Let's do the same underneath it, so E on the keyboard, and we will do the same for the 4 outer arcs. Select this one and this one, E for equal. Now we can give a radius to this arc here, so Shift R on your keyboard for a 15mm radius. We will select these 4 arcs here and press E on the keyboard for a equality constraint. I will give them a radius of Shift R 30mm, and we need to constrain this vertex here to this line, so select the vertex, then the line, and Shift O on the keyboard for a point on object constraint. We will do the same with the other ones, so Shift O on the keyboard, select this vertex here, this line here, Shift O, this vertex here and this line here, Shift O, and we have a fully constrained sketch that represents the outer perimeter of our model, and I think we are missing the center circle. We don't have it, so we will import this geometry, use the circle tool, let's create a nice circle, select this external geometry and our circle, E on the keyboard for a equality constraint. Let's close our sketch and test to see if we modify the dimensions in our master sketch, if we don't break the model. So let's try 140mm here, 50mm here, close the sketch, and as you can see, our model outline follows the dimensions dictated by the master sketch. Let's close this. Let's get back to our original dimensions, so 130, 40mm, close. And now all that's left to do is to pad our sketch, so let's pad it for 15mm. Hit OK, and we're pretty much done. At this point we can select our body, press Ctrl V on your keyboard, let's choose aluminum as material. I want a shape color something like this, and we will play a bit with the material properties here. I will make it a bit more shiny, so let's try 15%. The specular color needs to be something a bit bright. Close this one, close. OK. Because we're using LinkStage3, we can choose the shadow display mode. Select the name of your file. I want ground transparency of 1, and we're pretty much set it up. OK, so now onto the next step. What we want to do is to create this slope here on the model, and to do this we will use a Revolve cut. So getting back to our model, select this circle here, and we will create a datum plane. I want to rotate this datum plane around the y-axis by 90 degrees, and also around the x-axis by 90 degrees. Hit OK, and you will see why I rotated the datum plane this way in just a second. So select the datum plane. I will create a new sketch. I will import this external geometry, and by using the polyline tool I will essentially create the shape that we will use to create the slope on our model. Right click to dismiss the tool. By using this icon here we can rotate the view to be aligned with our sketch. Select these two vertices here and shift V for a vertical constraint of 3 millimeters. And I don't know why this vertex here should be coincident with this vertex here. Okay. Let's close the sketch, hide the datum plane, and using the revolve cut and the base z-axis we will cut our model. As you can clearly see, the sketch was not enough to do a clean cut, so let's make sure that it is correct this time. Okay, so this concludes the creation of the sloped part of our model. Let's see what the next step would be. So the next step would be creating the 4 holes for our model. Let's get back to our file. Let's unhide our master sketch. Let's hide the model for just a second, so select these 4 circles here, unhide the model. What I will do now is to create a pocket reversed through all, and the important part here is to give it a fit tolerance, because we essentially need only the center of our 4 holes. Let's click OK, select the geometry of our 4 holes, and we will use the hole tool. I want the profile to be a isometric one. I want the size to be a MS6 or 8, I think, and I want a DIN standard hole type. Click OK, and we have this way our 4 holes. Okay, let's hide the master sketch for just a second, and now we're getting into the part where we need to create the 2 internal pockets. To do this we will use some Boolean operations, and these are offered in LinkStage3 directly in the part design workbench. We will start by creating the geometry that will define the shape to be cutted from our main body piece. One thing that I will do now is to activate AutoSolid group. What this will do, if you take a look, will revert the order of the tree view with your latest feature at the top, and we will take advantage of the possibility in LinkStage3 to have multiple solids inside the same body. We will create a new sketch. We will map it on the XY plane, hit OK, and let's hide our geometry for just a second. We will unhide the master sketch, and I want to import some external geometry, which will be this one, and this one. I want to create 2 arcs that will be tangent to our circle here, another arc here. By hitting the center of our sketch I will create another arc here, and a connecting one here. Let's apply the tangency between these ones, so select the 2 arcs, press T on the keyboard. Let's do the same here, T on the keyboard, OK, and using the line tool we will connect these ones here. OK, I need to import some other geometry, so select this one and this one, select this edge and this geometry here, and we will give it a parallel constraint, and we will do the same under here. So parallel constraint, and what I need to do is to have this vertex here and this vertex here symmetric to the horizontal axis of our sketch. So select the two vertices, the horizontal axis, and press S on the keyboard for a symmetry constraint. Let's close our sketch, and we need to move it up by 20 millimeters. So select the sketch, we will expand the attachment offset in the position field, we will move it by 20 millimeters in the Z direction. Now select the sketch, let's pad it, reversed, and the important thing here is to make the operation as a new shape. I will unhide for a second our geometry, and as for dimension I want to pad it for 17 millimeters. Hit OK, and we essentially have the shape that will cut our internal pockets. Now I want to select our pad, and bear in mind that this is a separate geometry, a different solid in respect to our geometry that we've done previously. So let's select our pad, we will create a mirrored feature, hit OK. We will hide for just a little bit the geometry here. Let's hide our master sketch. I will select by pressing Ctrl on the keyboard these edges here, and I will create a fillet with the radius of 6 millimeters. Hit OK. Now let's unhide our master geometry. I will create a shape binder that we will use to cut this geometry here. So let's select this face here, this face here, and this face here, and we will create a green subshape binder. Now there is a really important step that we need to do here in order for our successive operations to succeed, and we need to set the fuse property of our shape binder to true. This essentially will make so that the geometry kernel inside the FreeCAD will treat the geometry of our shape binder as a unique contiguous shape and can be successfully used to cut our geometry. I will unhide the geometry of our fillets. I need to move or offset the position of the shape binder, and by expanding the placement property position in the Z direction I will offset it by 7 millimeters. Okay, now select the binder, select by pressing Ctrl the fillet, and we will use the split operation. So hit the split operation, and we will activate this geometry here that we need in order to have the two paths in our model. Let's tweak a little bit the position of our binder. I will now proceed at creating some fillets, so select these two edges here, and let's create 8 millimeters fillet, hit OK, and now I want this face here, so essentially the bottom of our pads to be filleted, perhaps 5 millimeters. Hit OK. Let's unhide our main geometry. I will select first the fillet, then the geometry of the hole, and we will do a Boolean operation, and let's set it to cut. And voila! We have our complex geometry that follows the slope, the external slope of our geometry. So let's switch to wireframe, and we're pretty much done. Hit OK. Let's switch to shadow, perspective view. We need to hide the geometry of the hole, and that's pretty much it. One question that I was asked how I set it up per face colors for the model, so we can select the faces that we're interested in, by holding down Ctrl, then right click on the last feature of your tree view, set colors, and a dialog will be opened to set the colors for those particular faces. Let's hit OK, and we're pretty much done. Thank you for staying till the end. It was a long one, and I hope to see you really soon.